Okay, so on to the next set of questions. Again, look for the differences. If the differences are the same, in this case it's 9, then it's going to be a 9n rule. The first term is 9, so there's no additional work that I have to do. In the second sequence, you can see the numbers are increasing by 7, so it's going to be a 7n rule. Is the first term 7? No. You have to take 6 off, to get the first term. So this looks as if it's going to be a 7n take 6 rule. Let's just check with the second term. Second term, 2 7s are 14, take away 6 is 8. Third term, 3 7s are 21, take away 6 is 15. So that's that one. With question 6a, it's going up in 6s, so it's a 6n rule. The first term isn't 6, it's 2, so I have to subtract 4 to get the 2. Check with the second. 2 6s are 12, take away 4 is 8. 3 6s are 18, take away 4 is 14. So I know that I've got that right. Now, this method of finding the nth term only works if the differences are the same each time. If you take a look at question 6b, you will see that that isn't the case. The first difference is 3, the second difference is 5, the third difference is 7, and so on. So this isn't going to be an nth term rule in the same form as the previous ones. At the level we're working at, if that isn't the case, if those numbers aren't always the same, then the next thing you should think about are square numbers. Okay, and what you'll see here is that that is 1 squared, that is 2 squared, that is 3 squared, 4 squared, 5 squared. So the nth term rule would be n squared. Whatever number, whatever position in the sequence we are, you square it to get that number. So the 7th term would be 7 squared, which is 49, and so on. So remember, if you don't have the same difference every time, look for other things that we need to know about at this level, and squared numbers would be the next best thing. For part C here, again, these aren't going up with the same difference every time, but hopefully the way that it's been laid out, you will see that what we've got here each time is the square number has been multiplied by 4. 1 times 4 is 4, 4 4s are 16, 9 4s are 36, 16 4s are 64, 25 4s are 100. So what actually this is doing is taking your previous sequence and multiplying it by 4. Well, we know the previous sequence was n squared, so this one is going to be 4n squared. So when you're working on questions that are sort of split up A, B and C, then quite often the third part of it will be built upon what you've done previously. Okay, so you need to be a little bit switched on with a sequence if it isn't a constant difference as it was previously. The other way that they can mess with your head with these questions is by writing products in the sequence. So you can see here the first term is 2 times 4, the next one is 3 times 8, and what you do here is you look at each one separately. So first of all, let's take a look at what's going on here. The first part of it is going up by 1 each time, so it's a 1n rule, which is 1n or just n. But the first term isn't 1, it's 2, so you have to add 1 to make it. Okay, so the first parts of these multiplications are going to be given by 1n plus 1. Now if we then look at the second part, so the bits I'm underlining now in green, again, what's happening? Well, that is going up in 4s, so this part of the sequence is a 4n rule, and you'll see that the first number is 4, so that's all we need to do. So this particular sequence looks hideous. It's 1n plus 1 for the first part of it, multiplied by 4n for the second part, and that's the end of that. And then for the second sequence, we're going to have this one's going up in 6s, so we're back now to the normal method. This is going to be a 6n rule. Is the first term 6? No, it's 4, so we have to subtract 2. Check it with the second term. 2 6s are 12, take away 2 is 10. 3 6s are 18, take away 2 is 16. So we know that that's our rule. The other thing they can give you is, rather than ask you to find the rule, they'll give you a rule, as they have here, n squared take 4, and you have to work out what the second term is going to be. So the second term would be 2 squared, take away 4. 2 squared is 4, take away 4, so the second term is 0. The third term will be 3 squared, take away 4. Well, 3 squared is 9, take away 4 is 5. So usually on the foundation paper, the nth term sequence is as straightforward as finding the common difference and working from there. But if the difference isn't the same every time, then you need to think of square numbers or multiples of square numbers, or they may be really evil, and write down the sequence as products as they have there in question 7. But the chances are it'll be a more straightforward question you'll be given.